Chapter 4. When we stand in the sun or sit near a fire, we feel hot. When we touch a lump of ice, we feel cold. When we dip our finger in warm water, we feel warm. Thus, we feel cold, warm, or hot. Heat is a form of energy which causes the sensation of hotness and coldness. Activity 4. Sensation of touch is not reliable to find the degree of hotness or coldness of the body. Things needed: 3 bowls, ice, cold water, hot water. Method: we take 3 bowls, mark them as A, B and C. We pour some hot water in the bowl marked A. Warm water by mixing some cold and hot water in bowl marked B, and ice-cold water in the bowl marked C. Now, we dip the fingers of our right hand in bowl A and the fingers of our left hand in bowl C for some time. We now put both the hands simultaneously in bowl B. Do both the hands get the same feeling? Observation: we feel cold on our right hand and hot on our left hand, though our hands are in the same bowl. Temperature. We have just discussed that the hotness or coldness of a body is something relative. We can measure the degree of hotness or coldness by comparing it with a standard that we all agree upon. The degree of hotness or coldness of an object on some chosen scale is called its temperature. Temperature of an object is measured with an instrument called thermometer. Laboratory thermometer. The laboratory thermometer is used for measuring temperature of substances in science experiments performed in the school laboratory. A common laboratory thermometer can measure temperature from -10 degrees Celsius to 110 degrees Celsius. Clinical thermometer. When a person gets fever, his body temperature rises. A clinical thermometer is used to measure the body temperature of human beings by doctors in hospitals or at home. A clinical thermometer has a very short temperature range from 35 degrees Celsius to 42 degrees Celsius. How to use clinical thermometer? Before using, the thermometer should be washed preferably with an antiseptic solution and dried using a cotton swab. Hold the thermometer firmly and give it a few jerks. The jerks will bring the level of mercury below 35 degrees Celsius. Now, place the bulb of the thermometer under your tongue for about 2 minutes. In case of a child, place it below the armpit and not in the mouth. After 2 minutes, take the thermometer out and read the mercury level of the thermometer by holding it horizontally in the line of sight. This is your body temperature in degrees Celsius. Activity 5. To find the temperature of hot water. Things needed: iron stand, laboratory thermometer, beaker. Method: we take an iron stand and suspend the laboratory thermometer from it. We place a beaker containing hot water whose temperature is to be measured under the thermometer. We make sure that the bulb of the laboratory thermometer completely dips in water but does not touch the sides or base of the beaker. The mercury in the bulb gains heat and expands. As a result, the mercury moves upwards in the capillary tube. When the temperature of mercury becomes equal to that of hot water, the mercury thread will stop rising
and stand at one place. We read the temperature from the scale at which the mercury thread stands. This will give us the temperature of hot water. Now, tilt the thermometer in hot water. Let it touch the surface of the container. The level of mercury begins to fall. This means that the temperature must be read when the bulb is surrounded from all the sides by the substance of which the temperature is to be measured. Now, take out the thermometer from hot water. We will notice that the level of mercury begins to fall. It is clear that the temperature of hot water must be read while the thermometer is in hot water. Activity 6. Transfer of heat. The flow of heat from a body at higher temperature to another body or to another part of the same body at lower temperature is called transfer of heat. Imagine our teacher has to distribute answer sheets to the students in the class. He can do it in 3 ways. He can hand over the answer sheet to the first student and ask him to pass it on to the next student. The next student passes it on to the next, and so on. In this way, the last student can receive his answer sheet without actually moving from his place. The teacher may ask all the students to line up, call one student after the other to come, receive his answer sheet and go back. The teacher may throw the answer sheets directly to the students without disturbing those sitting in between. In nature, there are 3 distinct ways in which heat is transferred: conduction, convection, and radiation. Let us study these 3 modes of heat transfer in detail.
Conduction. If we heat one end of a steel spoon by keeping it over a gas burner, we find that its other end also becomes hot after a while. In this case, heat is transferred from the hot end of spoon to its cold end by conduction. The transfer of heat by the process of conduction takes place only in solids.
Activity 7.
To show that heat travels through solids by conduction. Things needed: flat copper rod, wax, iron nails, burner. Method: we take a flat copper rod and fix some small iron nails at equal gaps on it with the help of molten wax. This copper rod, along with its iron nails, is clamped to a stand as shown in the figure. Let us heat the free end of the copper rod by keeping a burner below it. Observation: we will see that the nail nearest to the heated end of the rod falls down first, then the next, and finally, the nail farthest from the flame drops off last. Conclusion: these observations can be explained as follows. The burner is placed below the free end of the copper rod. This end gets heated first, whereas the other end is cold. The heat travels gradually from the hot end of the copper rod to its colder end. It melts the wax which holds the nails. Due to this, the nails fall down one by one. From this activity, we conclude that heat is transferred from the hot end of copper rod to its colder end by the process of conduction.